This is Lesson 1. In it, we will discuss algebraic expressions, mathematical models, and real numbers. Or more specifically, what is an algebraic expression? How do we evaluate it? How do we use mathematical models? And what are some properties of real numbers? So let's start by talking about algebraic expressions. So what exactly is an algebraic expression? An algebraic expression is a combination of variables and constants, or numbers, if you will, that use various operations such as addition, subtraction, multiplication, division, powers, or roots. Two examples of algebraic expressions might be x plus 6 or 2x to the third plus x squared minus 8. Notice we have no equal signs, we have constant numbers as well as variables, and we have operations. So these are typical examples of algebraic expressions. So next we might ask, well, how do we go about evaluating an algebraic expression? Now, whenever we evaluate an algebraic expression, the first thing we must do is follow the order of operations. Since you're going to have various operations in your expression, you have to know which you do first and in what order you do them. Now, probably the best way to remember order of operations is to think of the word PEMDAS. Now, each of these letters represents a particular operation and the order in which you should do them. So the first things we should do is letter P. Well, what does letter P stand for? Letter P stands for parentheses. If you have any parentheses, you work on them first. If you have multiple parentheses, you start on the innermost parentheses and work out. Next is the letter E. E means exponents. If you have any exponents, that's the next thing you should perform. So, for example, in our above example, we had 2x to the third. Obviously, we're going to do x to the third. We're also going to do x to the second. Those operations we have to do before we do the addition and subtraction. Next, we have M and D. M and D refer to multiplication and division. All right, so we're going to do multiplication and division next. Now, if you've just got multiplication and division, you go left to right. Even if division occurs before multiplication, you'll do the division first and then the multiplication. Okay, so you're always reading from left to right, and you're going to do the multiplication and division. Finally, AS refers to addition and subtraction. In this case, again, if all you've got left is addition and subtraction, you go left to right and perform those operations. Even if subtraction is first to the left and addition is to the right, you'll do subtraction first and addition to the right. So now let's look at a particular example. Let's say I take one of my examples up here, the 2x to the third minus x squared minus 8. So let's say I want to evaluate that expression for x equals 2. So basically all I'm going to do is take the value 2 and substitute it for x in this expression. So I'm going to substitute it for the first x as well as the second x. And if I do that, I now have 2 times parentheses 2 to the third power plus 2 in parentheses raised to the second power minus 8. My result simply comes out to be 12. So I've evaluated my expression for x equals 2, and my expression when x is equal to 2 is equal to 12. Now let's talk about mathematical models. Now, if you think back to when we were talking about algebraic expressions, if you have two expressions and you set them equal to each other, you end up with an equation, okay? An equation is any time you've got an expression with an equal sign, okay? Think of the first four letters of equation, EQUA. Well, that's also the first four letters of equals. So two expressions equal to each other result in an equation. Now, often equations can be used to model real-world functions or activities, okay? And this is when we refer to them as formulas. For example, this formula, h is equal to 0.9 times parentheses 220 minus a, is a formula to calculate the maximum heart rate when you're exercising. Now, h is equal to your heart rate. A is simply equal to the difference is equal to your age. So the maximum heart rate you have when you're exercising is equal to 0.9 times the difference between 220 and your age. This is an example of a typical mathematical model. So now let's talk about real numbers. What exactly are real numbers? Well, you can think of the natural numbers or the counting numbers, 1, 2, 3, 4, 5. Those are all real numbers. You can think of integers. Those are real numbers. You can think of rational numbers. Those are fractions like 1/3, 1/4. And you can think of irrational numbers such as the square root of 2, the square root of 3. These are all real numbers. Now, one way we can represent real numbers is by means of a number line. This basically is a graph representing all the real numbers. Now, this blue line which I've drawn here represents a number line. Now, typically on a number line, although not always, the center of the number line represents 0. And everything to the right represents all positive real numbers. So we've got 1, we've got 2, we've got 3, and we just keep on going forever to the right. Now, numbers to the left of 0 represent negative numbers. So to the left of the first number to the left of 0 is -1. Then we've got -2. Then we've got -3. And these continue on infinitely to the left for all the negative numbers. Now, the line obviously has infinite number of dots, okay? So all these points between 0 and 1 represent all the real numbers between 0 and 1. Similarly, between 1 and 2, 2 and 3, and also on the negative side, between -1 and -2, all the values between those two numbers are represented on the number line. Now, one thing you'll notice is, as you're going to the right, the numbers increase. As you're going to the left, the numbers decrease. For example, 1 is less than 3. Okay? And notice the symbol that I use to represent less than. So 1 is less than 3. I could also say that 2 is greater than -1. Because 2 is to the right of -1, so therefore 2 is greater than -1. I could reverse this and say -1 is less than 2 because -1 is to the left of 2. Okay, so this is how we represent order, greater than or less than on the number line. So now let's talk about absolute value. Let's say I'm talking about a number A. Okay, the absolute value of A, okay, is basically the distance the number A is from the origin. For example, let's say that I had the absolute value of 2. Well, how far is 2 from the origin? It's 2 units from the origin, or the absolute value of 2 is 2. Now, what if I had the absolute value of -3? How far is -3 from the origin, or 0 in this case? It's 3 units from the origin. So therefore, the absolute value of minus 3 is 3. Now notice, with absolute value, your distance is always positive. There's no such thing as a negative distance. Now what about if I want to know the absolute value of the difference of two numbers, the distance between two numbers on a number line, for example. Let's say I want to know the distance between minus 1 and 2. Well, the distance between minus 1 and 2 is simply the absolute value of the difference. For example, if I have minus 1 minus 2, the absolute value of that is going to come out to be 3. Now, it doesn't matter the order in which I do this. I could also have said the distance from 2 to minus 1 is 2 minus a minus 1 difference. 2 minus a minus 1 is 3. The absolute value of 3 is 3. So the distance between any 2 points on the number line is simply the absolute value of the difference of those two numbers. Now let's talk about the properties of real numbers. All right, let's say I'm adding two real numbers. Let's say I've got, what do I want here? Let's say I've got 2 plus 3. Well, that's simple enough. That's obviously equal to 5. Well, there's a property called the commutative property of addition, which says I can say 2 plus 3, or I can say 3 plus 2. And in both cases, it's simply equal to 5. So basically what this is saying is the order you add numbers doesn't matter, okay? Similarly, I could have multiplication, and I could say 2 times, and let's use parentheses here. 2 times 3, well, that's obviously 6. Well, that's the same thing as 3 times 2. So just like there's a commutative property of addition, there's a commutative property of multiplication. When you're multiplying two real numbers together, the order that you multiply them does not matter. Now there's also something called the associative property. Let's say I've got 2 plus 3 plus 4. Okay? Now, how do I want to do that? I could say, well, let's add 3 plus 4, which is 7, plus 2 is 9. Or I could have said 2 plus 3 is 5, plus 4 is 9. Okay? So this is the associative property of addition. How you group the numbers when you're adding them together does not matter. Grouping does not matter, okay? Now similarly, I could say 2 times 3 times 4. And I could say, well, 2 times 3 is 6, 6 times 4 is 12. I could also say 4 times 3 is 12 times 2 times 3 is 6 times 4 is 24. I could also say 4 times 3 is 12 times 2 is 24. So how we multiply, the associative property of multiplication, I could change this to be 4 times 2, which is 8, times 3. And in all cases, this is equal to 24. This is the associative property of multiplication. Finally, we're going to talk about the distributive property. Say I've got 2 times 3 plus 4, okay? Well, that is simply equal to 2 times 3 plus 2 times 4. Which obviously comes out equaling to 14. Finally, let's go back to our discussion of algebraic expressions and talk about simplifying an algebraic expression. So let's start out with a fairly complicated algebraic expression. 6 parentheses 2x squared plus 4x parentheses plus 10 parentheses 4x squared plus 3x parentheses. Okay, using what we know from this lesson, let's start off by distributing the 6 and the 10. So after we've distributed, we end up with 12x squared plus 24x plus 40x squared plus 30x. Now, we look for what are referred to as like terms. Okay, like terms are terms which have the same variable in the same degree. For example, if you look closely here, you notice we have an x squared term right here. Well, we also have an x squared term over here. So these two are considered to be like terms. Also, notice we have an x term right here and another x term right here. Those are considered to be like terms. So we can combine or add these like terms. So our result after combining these like terms is 52x squared plus 54x. So this is how we basically simplify an algebraic expression, by combining the like terms, which makes the number of terms in the expression less, and just simplifies and makes your work a lot easier if you're evaluating this. Now, using what you've learned in this lesson, I'd like you to take and try the first worksheet related to this lesson. I've got the answers there. Take a look, see if you can do all of these, and once you feel comfortable that you understand all of the problems, go on to do the quick quiz at the end of that and see how you do. And finally, if you have any questions, feel free to contact me either via discussion or via email.